Right. The next mechanism we talk about is nucleophilic substitution of haloalkanes. So you have got your 1,2 carbons there. So it's 1 bromoethane plus sodium hydroxide aqueous. It works as a nucleophile. You end up with your alcohol plus sodium bromide. Now the mechanism for this is like this. It's very simple. So you start by drawing your CH3. Sorry, my camera is shaking a bit. So you start with your drawing your haloalkane, which is a CH3, CH2, Br. Okay, and what you do next, you got your OH minus a lone pair. Actually, AQA people like you to put the minus together there, so you can put that one there. So you got a delta plus and delta minus and a dipole there. So the negative to positive. So the curly arrow goes from the double bond, the lone pair on the OH or the negative charge, to the positive carbon, and this bond will break and release your bromide ion with 2 extra electrons. Okay, so the next step you end up with is your CH3, CH2, OH, okay, and then you have, sorry, I should have shown you that bit, plus Br minus comes out. Okay, so that's the substitution of haloalkane. So I've got my phone. I'll just show you this bit here together, so you know. Just to show you now that you start with your haloalkane and you form your alcohol. So if you got a haloalkane which is secondary here, you get a secondary alcohol. In this case, you get a primary alcohol. Okay. So this is the next mechanism. Right, the next one I'm going to show you is how to make nitriles from haloalkane. So you got your haloalkane again, and you mix with the KCN and ethanol, you reflux that, and you end up with your nitrile plus KBr comes out. Now, if you notice something, you have an extra carbon added to the chain, so it's a bonus thing. So if you want to increase your carbon chain. So how do you start that? I'm going to show it to you. So you got 1, 2, like that. Then you have your CN minus with a lone pair there. So it's the same thing happens. So the CN will attack your carbon and the bond will break. So you end up with your CH3, CH2, and C triple bond N. Plus you have your Br minus leaving. So that's how you do that mechanism. It's the same as before, but it's with CN, so you make a nitrile. Now let's go make amines from a halogen alkane. So let's look at the mechanism. So the mechanism like this. You start with your just see if you can see it, CH3, CH2, Br. Okay, so you have your delta plus and delta minus there. You have a molecule of ammonia arriving there with a lone pair. Never forget a lone pair from ammonia. So the lone pair will attract itself to the positive carbon. So it needs to be a curly arrow. Sorry, this is not good. And then the bond will break. Then you form your carbocation like that. Like that. Now you have 3 hydrogens attached to your ammonia. Okay, and then what it means is a positively charged molecule there. Now carrying on where we stopped is that there's another molecule of ammonia which just arrives here. Okay, so the second molecule of ammonia arrives. Can you see that? Right. So it's still got a lone pair there. So the lone pair will get attracted to one of the hydrogens. It's still one of the hydrogens there, and that will donate a pair of electrons there. Okay, so it's always negative to positive. Okay, so the next step is that's your carbocation. So what happens is you have your now your amine is formed. Plus NH4 plus comes out. But mustn't forget on the first step you got the Br minus coming out, because I forgot to tell you that. So that's how you make, that's for another nucleophilic substitution reaction of haloalkane. Right, now we're going to do is elimination reaction of haloalkane. So that happens when you got your haloalkane and it reacts with hydroxide in ethanol. So hydroxide becomes a base, is no longer a nucleophile. Okay, so you end up with a CH2, CHH, CH3, and then you end up with water and KBr coming out. And I'm going to show you the mechanism of this reaction. So I've got to put here mechanism. Right, I need to hold the camera because my table is shaking. So if you got the OH coming here on this side, so I'll put it here, HO with a negative and a lone pair. So that will attract that hydrogen there, which is, you got a Br here, don't you? And then that bond will break and donate a pair of electrons here. Okay, and then you have your Br leaving. So there's 3 steps going on in there. The next step here, you end up with your CHH double bond C, CH3 and H. So you got an alkene formed. Then you have water coming out plus Br minus. And that's the mechanism for elimination of haloalkane.